Okay, is it coming through? All right, good morning. My name is Steve Maher. I'm with Risk Management Professionals. It's now 8 a.m. Pacific Standard Time. So we'll go ahead with our continuation of our Hazard and Operability Study Facilitation Seminar Series. We're going to be focused on quality today. It's Module 11 for those of you who've been attending all the different HAZOP study course modules. And like I said, we'll be focusing on quality. But first, a little logistics. You are using a GoToMeeting interface. That's our primary interface for our outreach programs. This is basically part of our, we do a lot of work in process safety management, risk management programs, and SEMS. So we have an ongoing series of PSM modules and also HAZOP study modules as part of our outreach program to try to communicate best practices. It also helps keep us on our toes with making sure we're aware of best practices and are adhering to the best standards of the industry. In terms of using this GoDaddy interface, you should see two small windows on your screen, one a small video of me and one a larger picture image of the slides that are being displayed. Those sizes are adjustable, and you can also move the location of the video image or the slide image around on your screen. This tool provides us with a lot of flexibility. During the presentation, you'll be on mute so that you can do your job at your desk, shuffle papers, answer the phone, and all the other participants aren't hearing what you're doing. However, you do have a live chat feature that can go right to our producer, Tim Lee. If you have an urgent question or urgent issue, you can go ahead and send it to him, and he'll respond. If it involves getting my attention, he can also get my attention. We'll be using that interface. Most people seem to be most comfortable with that interface for our question-answer period at the end. But if you'd like to, you can also be unmuted if you'd like to join part of an open discussion. Also, if you are having any technical difficulties, sound, video, whatever, go ahead and contact the 877 number that you see on your screen, 877-532-0806, and somebody will do their best to help you out there. All right, so just by way of a little bit of background, Risk Management Professionals is a PSM, RMP, and SEMS consultancy. We do focus on these activities. We help a lot of people build programs, but we get involved a lot in individual elements, helping with operating procedures, training. We get involved a lot in the hazards analysis area, doing HAZOP and LOPA, fault tree analysis, quantitative risk assessment, SIL assignment, SIL verification. That seems to be a very popular service that people like to call us in for. I think it's because they just don't want to do it themselves, and they really would prefer to get some folks who do it on a day-to-day basis involved. The whole purpose of this outreach program is to share some of these insights, share some of our best practices so that others can benefit from it. As I mentioned, we're part of this is Module 11 of our HAZOP Study Facilitation Series. We've already talked about the things that drive it, the regulatory requirements, some consequence analysis, and some quality tips. Quality is something you're always building on, so we felt like a specific module for that was important. Also, key preparation activities and P&IDs, how to detail scenarios, facilitation tips, some workshops on common mode failures and defining scenarios, how LOPA, SIS, SIL, QRA, everything links together, and how do you do this during the design process, which is a key opportunity to use these techniques to really make your design safer with the lowest potential cost that you'll invest on making it safer. Module 9 was on vendor package HAZOP studies. Module 10, which was the last one that we addressed, really focused on some of the evolving changes that are going on in the regulatory arena to address what were perceived as deficiencies in the overall process hazards analysis process. So Module 10, we focused on what are those tools that are out there, HAZOP being the workhorse of the industry, LOPA helping you get a different slant on the scenarios that you define during the HAZOP to provide some more quantitative definition of things. That was a key focus for Module 10, and when it was presented, it was also bringing into play a lot of the PSM, RMP guidelines that are evolving, and also CSB recommendations for changes in the technology and regulatory requirements. That's also a moving target. So we'll be having another webinar in January to build on that and provide an update for what those regulatory changes are. So Module 11 is going to focus on HAZOP and LOPA documentation quality tips. And I need to switch screens, so is Tim, so excuse me for a second. Got it? All right, good. So as I mentioned, we're kind of trying to build on what we discussed previously for our HAZOP modules. As I mentioned, these are evolving areas, and HAZOP and LOPA quality has been identified as an increased interest from regulatory scrutiny perspective, and also there's a significant potential for capital or recurring costs associated with instrumentation over-design if the HAZOP or LOPA isn't done with good quality. And so the purpose of this webinar is to provide some quality tips to help move those forward. We'll be going over a number of different topics. We'll be talking a little bit about resources, preparation, what do you do during sessions to make sure that you have a good quality outcome. But the focus will be on documentation, and we want to also provide some insights on how to pull together a quality program. And also, I think what will be especially of interest is common quality challenges. What do we see? We're out there all the time working in a number of different industries, doing HAZOP and LOPA studies. We're also working with lots of different clients all over the world. So we see lots of different things, and what we wanted to do is share with you some of those common challenges that we see that you should keep your eyes open for. And also as part of this, we've got a one-page slide on if you're auditing or doing a quality assurance review of a HAZOP or LOPA, what sort of things that you can practically look out for without, of course, redoing the entire HAZOP and LOPA. So the first thing we need to start with is why quality? Why bother to do a good job in the first place? Doing a good job the first time is usually the right way to go. And really, there are experiences, the things that we've seen work, the things that we've seen don't work, really build on that old adage. When you're looking at a lot of the tragedies that have occurred in the past, process safety, things that haven't gone right for process safety seem to be at the core of what's gone wrong. And a key part of process safety is understanding the hazards. So realistically, the HAZOP and more recently the LOPA has been a tried and true tool for going out and evaluating hazards. They've been shown to be effective. They're endorsed methods. And although nothing's ever 100% in life, the fact is they do a very good job for cost-effectively flushing out potential weaknesses or vulnerabilities in design or operations. So from the standpoint of protection of life, protection of the environment, protection of property, identifying hazards properly is important. So from that perspective, HAZOP and LOPA quality is important. Also, during the same period that you've seen an evolution of regulatory guidelines and industry practices associated with process safety, there have also been numerous advances in electronics, protection systems, understanding the reliability of key standby protection features. All those things have been evolving significantly in the past 20 years. Well, helping make decisions on where do you invest your money for the type of reliability that you want to achieve, and is the reliability satisfactory, is very important. The HAZOP, LOPA techniques push you in that direction. So obviously from a cost-effective implementation of key safety systems, the quality of your HAZOP and LOPA is also very important. What are these tools? Most of these tools are scenario-based, understanding what can go wrong. In this image, you see 5 different scenarios where you're looking at likelihood, you're looking at the severity of it, and you're trying to link those together to determine the importance of the scenario. That's a fundamental aspect of understanding the hazard, and are there any gaps in the design, and what do you do with it? Obviously, the HAZOP and LOPA, if you're using those tools, the quality of that is very important for clearly identifying the scenarios and where you want to go with things. So there's a lot of hazards analysis tools out there, and we've been reviewing those in previous modules. The HAZOP, the LOPA tools, like I said, are key common tools that are out there. A lot of other tools are also available, and doing a quality HAZOP and LOPA allows you to link to those tools, use them as appropriate to provide you with additional insights without completely redoing and reworking everything. So that's another reason why the importance, the quality of the HAZOP and LOPA is very important. And so let's talk about two key elements of that now. Basically, resources and approach, and also the session dynamics. Having the right resources and using the right approach are really good starting points for your HAZOP and LOPA. So what we want to do is take a look at some of the key elements that move you in that direction. The items in red are deliberately identified for emphasis. Having a facilitator and technical experts on your team who are qualified, they're the right people for the job. They're not like a sales representative who doesn't have a technical background for your vendor package. It's somebody who really knows the ins and outs of the design and can really speak to what happens if you're in an upset condition and to look at the process dynamics. Qualifications, experience, and also a key part of that is preparation. A lot of people don't realize the depth that you go into during a good HAZOP and LOPA tool technique or approach. And having a team that's got all the information, it's been reviewed, they're ready to answer questions, they've thought through the system dynamics. It makes a world of difference in terms of the quality of your effort and your ability to really move that team forward. We do also obviously lots of bidding on HAZOP and LOPA jobs, and clients are usually asking us for estimates on team session length, and we do a pretty good job. But the real pivotal factor for that is the preparation of your team. Who's on the team? What have they done their homework? Are they ready to go and answer questions and really dive into that? The facilitator is the same way. An old school approach to this was, hey, the facilitator doesn't need to know anything about the process. They can just show up and ask questions like no flow and more flow and high temperature and low temperature. But the reality is, driving the team to really identify potential weaknesses does require a lot of preparation. You want somebody who's guiding the team, who's spent some time, prepared, looked over the drawings, thought through the process, and can really drive the team to be at their best. It's extremely important. The third item, quality checked, complete, and field verified engineering drawings. It may seem very obvious to most of you that you want to have correct information so that you have good information to go into your process, and then you've got good information coming out. Unfortunately, that's not always the case. Invariably, there's always little mistakes in piping and instrumentation diagrams and other engineering information. Doing a quality check, field verification to minimize those so the team can really focus on their job rather than on correcting something that could have been done beforehand is super important. So all these things are key elements of having the right resources and using the right approach to make sure that the outcome of the HAZOP and LOPA is good quality. Another key foundation is what's going on during the team sessions. The interaction of the team, how they're working together. I call that session dynamics. Basically, making sure your knowledge base is there. I mentioned that under preparation and your resources and your approach. Making sure that the team has that information and has the ability to understand the response to upset conditions and what happens. Instrumentation and set points. I've been to a lot of feed studies during a design process, early in the design, where a lot of the instrumentation issues haven't been well thought out. It really limits your ability to help identify if there's any gaps in your safety functions. If you don't at least have an initial thought in terms of set points and what safety instrumentation is out there. And we'll be talking more about set points later. Control and protection system actions. What happens when you reach that trip set point? And also how does the system respond? Also critical. Your team really needs to know that. For the team interaction, basically making sure that they maintain focus. That's a key part of the facilitator's responsibility, and they really need to do that as part of their job in facilitating the sessions. And also, something that you got to be aware of is you can take shortcuts for low hazard areas, or if it's not very complicated, but you will want to spend more time if there's very complex system interactions or a system response to things. Other things with respect to system dynamics is the facilitator support. They've really got to train the team, drive synchronization. They need to be really dialed in, understand the process, looking at the ultimate consequences, looking at those severity rankings, and make sure there's a lot of consistency there. They really need to encourage involvement, consistent risk ranking, making sure that you correlate the risk ranking to any recommendations that are coming out of that. And the facilitator needs to really have an ability to bring in other tools, to link to quantitative risk assessment and understand what's out there so they can make sensible decisions about what the team is doing. If you don't know what is needed for layer protection analysis, for example, you really can't do a good job for the HAZOP or know when to stop HAZOPing and say that, hey, we need a little bit additional quantitative information here. Another thing about session dynamics is managing drawing updates. For all of those of you who've done a HAZOP study during a design, you realize that the design is a moving target. If you can make manageable changes on the drawings that the team understands, then basically you've got a core of being able to have a good HAZOP study. But if the design has not been well thought out, if you're making too many changes and the team really can't do a good job understanding what's going on, you've got to know when to stop. You've got to know to say, hey, we're going off a cliff here. We don't have the right information. We're making too many changes. We've done some initial work here. Let's stop. Let somebody do their design and come back to it. So let's focus on the end result, which is documentation. You can either do, if you have good sessions, good preparation, good design information, you can have good documentation. Obviously, if you don't have a good HAZOP, you can't do a great job with documentation. So if you've got a good foundation, you can either choose to do a good job or not. So what we want to do is provide some tips on helping you do a good job documenting all the effort, which is incredibly expensive usually, that goes into doing a quality HAZOP and LOPA. So let's talk about with some general tenets for quality, and then we'll get into some specific examples. It's important to show that you've done a thorough job. The deviation lists, most people use something on the order of 1.5 to 2 dozen general deviations that include process deviations that include things like no flow, more flow, high pressure, low pressure, etc. The reason why that's important to stick to that, a lot of them don't really need to get a lot of attention for each node. There may not be a lot of issues associated with low ambient temperature conditions if you're in a hot part of the world, for example. However, all that said is you want to maintain discipline, you want to maintain that structure so that you can go back and find things later. So you want to make sure you go through the entire deviation list. And something that I think a lot of people lose sight of is the reason why you do things patterned and you make sure you do a thorough job is by doing a thorough job, your team really needs to think about what's going on. They need to think through the design, think through the process upsets, the dynamics of the upset condition, and that'll help them make sure that you do a good quality HAZOP or LOPA during session. If you rush them too much because some things seem trivial or inappropriate, it doesn't give them any time to think. And even if you're a sharp facilitator and can really hammer these things out, your team may not be used to thinking in this manner of what can go wrong. You want to give them some little break periods as you're going methodically through this list, and that'll help them regroup, think about those things, and really help you do a good job with the HAZOP study. Specific causes, things that you can touch, feel, or have experienced, specific pieces of equipment that can have a problem with them. Those are the things you need to focus on during a process hazard analysis. And also you want to make sure that you are specific with respect to what you're referring to, equipment tag numbers, P&ID references, etc. I don't know how many revalidations that I pick up that where the original effort was done by another facilitator when they may have done a poor job, and you're looking at a very cryptic valve closes as the scenario, and it's very time consuming to figure that out and guide your team in the right direction. A lot more to be discussed on that. Identifying the ultimate consequences, really focusing on what goes wrong, how bad can it get if the safeguards don't function properly. Then with respect to safeguards, make sure they're reliable, they're available, and make sure that they have specific equipment tag numbers and really exist, and there's enough process safety time for it to have the desired effect in mitigating the consequence. Those are all things that you want to make sure get addressed with respect to safeguards. Recommendations need to be provided whenever there's gaps, or you need to identify how that gap is to be closed. Operating modes need to be addressed. Also, there's a lot of other issues such as security, siting, human factors that need to be folded into the HAZOP. That's all part of making sure the analysis is complete and that translates into the documentation. Also, consistency with risk ranking, making sure the safeguards are consistently credited, and also the ultimate consequences have a consistent severity ranking, and it's clear what the ultimate consequence is. And we'll be providing some more examples in a minute. Also, the level of detail and scenario depth. If you're documenting a HAZOP study, how much detail you provide in that scenario description should be somewhat commensurate with the complexity, the level of importance, or the risk levels associated with that scenario. Documentation it needs to be usable. What happens with these things, and I think a lot of people who are with an operating company know this, is after the HAZOP study, everybody wants the action items because they want to get their action items done, call it a day, and finish their job. Well, to do that, they need to be self-standing. Invariably, this action list gets pulled out of the HAZOP study and handed to some poor soul who may or may not be been part of the HAZOP sessions, and they're responsible for implementing it. So if you're going to hand that off there, you can't count on that person who's just getting it to take the initiative to go back to the HAZOP study, to dig up the information, and even understand what was going on or the team's conclusions. So those recommendations need to be understandable, self-standing, a logical framework, some sort of link to what the problem was. So it needs to be complete. That's part of having good documentation. For traceability, you want to be able to go back and reconstruct what the team's thought process was. Scenarios need to be logically developed, complete, and understandable. They should paint a picture like you're watching a Hollywood movie of what's going on during that upset condition at the facility. I like to use the comments column quite a bit. Using that comments column, putting a lot of information in there. There are so many insights that the HAZOP and LOPA team come up with during their review. Capturing those so that it doesn't have to get rediscussed later is part of doing a good job, and you're going to save money later because somebody's made a decision, you've documented it, so you don't have to have other meetings, you don't have to readdress it, and you don't have to rediscuss and make that same decision again. And that's part of making sure their basis for the conclusions are understood so that people can pick that up later and clearly and cleanly and easily revalidate it. So, again, quality documentation is all part of not only doing a good job, but in the long run you can save a lot of money by minimizing rework. Making sure the scope and system boundaries are clear, team composition and experience, these are all basics. If a recommendation is there, it should either be linked to the scenario or as part of a self-standing recommendation. You want to go ahead and make sure that you provide some sort of basis for why somebody would want to take that action or make that correction or change the design. And also in red, this is the second time I'll mention it, we'll give somebody a prize if they can tell me how many times I'm going to talk about equipment tag numbers and how often they should be used. That is the #1 way to waste time during a HAZOP and LOPA. By not taking the extra 5 seconds to put in a tag number, it can sometimes take minutes or 5 minutes or more trying to figure this out later. And when you got a team of a dozen people all burning time because they can't understand what was documented just because somebody didn't put in a tag number, that's a lot of money, and that's a lot of wasted money that could be used much better applied elsewhere for your safety program. Cross-referencing equipment tag numbers, making sure these scenarios are clear, is all about doing a good job, and in the long run, you're going to save a lot of money for updating this. Also, as an added bonus, I almost sound like one of those infomercials. As an added bonus, if you do good equipment definition and tag numbers, gosh, it can be really handy for your management of change program later, because you've got that HAZOP study. You can search very easily, and you can find out the scenarios where equipment working, not working, or failing really had an impact. And that can help you make easier decisions and better decisions for management of change. And of course, recommendation closeout. This is about the #1 way to get a regulatory citation, if that's what you want, is to have action items that are out there and you haven't documented in some manner how you've addressed it or how you closed it out. It's really easy to do. If you have people of good conscience and technical capabilities that look through a recommendation and say, you know what, this is a great idea, but it just isn't cost effective, and it doesn't really have the safety benefits that the team thought originally, and oh, here's a better idea. I've never seen something like that in terms of addressing a recommendation be second guessed. Okay, so let's go through some examples. I'll start with the good, the bad, and the ugly, and then I'll go to basically, here's a good way to do it that will serve you better, is relatively easy to do, and will serve you better in the long run. In general, there are two truisms here. Having a pattern, it may seem annoying to have discipline and stick to a pattern when documenting causes, safeguards, consequences, etc. But the honest truth is, if you stick to a pattern, you can have other people helping you, and in the long run, that can involve about the same amount of effort or even less effort in some cases. Also, by establishing a pattern ahead of time, there's always a scribe, usually probably one of the least favorite jobs in the world, but there's usually a HAZOP or LOPA scribe who's capturing these things as the team is doing their HAZOP and LOPA session. Well, while the teams, I was trying to think of a word other than arguing, as the team's arguing over what the scenario is about and what should be documented, the scribe can go ahead and do some polishing if they have some clear direction on exactly what's expected of them. So, having a scenario that says pump fails as your causal event, at the time you're doing the HAZOP study, it makes perfect sense. There's 12.5 people in the room who really know what you're talking about. But when you do your documentation and hand it out and try to sort through things later, or heaven forbid, try to update it later, it becomes nearly impossible without a lot of extra time and energy and money spent trying to figure things out. So something a lot better would be to identify the pump name very clearly and matched with the P&ID. In general, if you match it with the P&ID, you'll be able to find it easier. And when you start using 6 different names for the same pump, it can get awful confusing. And what's the bad thing about confusion when you're talking about a safety analysis? That compromises the safety that you're trying to do. I've seen so many poor efforts that I've had to pick up, clean up, and update where it takes a lot of time to figure things out, and a lot of times they've got the wrong pump because they're really loose and inexact with respect to defining the exact pump name. And of course, a tag number, as we've discussed, and a P&ID reference is really helpful. I usually use a 20-second rule. If I've facilitated a HAZOP or LOPA and I can't find the thing in 20 seconds, it needs a P&ID reference. Saves time, easy to do, and helps address that specificity that you want. Also, how often do you put in tag numbers and P&ID references? Usually, if it's pretty well-focused system where you're looking at one page, one P&ID reference in the cause is fine. We'll talk about recommendations separately in just a few minutes, but one P&ID reference is fine. And also the first time in a scenario that the piece of equipment comes up, that would be a good time to identify a specific tag number. Another bad scenario would be valve closed. I see that a lot. Instead, identifying what the valve tag number is, what its failure mode is. In this case, it's a fail closed valve, and some sub-failure modes. Maybe somebody left it blocked in after maintenance. Maybe you've got a problem with the transmitter or controller. All those things provide a foundation for helping you sort through common mode failures later. If you're complete and identify some of the key sub-failures that could be part of common mode failures, common mode failures such as instrumentation or operator actions. Identifying the root transmitter is very helpful for sorting through common mode failures, and recognize that the HAZOP, even during a design process, isn't a one-use type document. The people who do the SIL assignments, who design the instrumentation, may be referencing that. So to the extent possible, if you put in those transmitters and controllers, it can really help them out. However, that's not always the best thing to do in terms of grouping things. Now, if you've got a control valve assembly that can be left blocked in, usually you've got a much higher failure rate if you're going through your typical LOPA initiating event frequencies compared to somebody leaving a block valve closed after maintenance, usually. That needs to be vetted by the team. If you're doing a LOPA and you've combined these types of sub-failure modes, and that one is very clearly low likelihood and the one dominates, then you can go ahead and stick with the dominant item as long as it doesn't affect your LOPA results. But sometimes, if you've got an operational block valve, where somebody may be opening or closing it during system operation, those are things that should be split out and looked at as separate scenarios. Also, if you've got a typical push-pull configuration on a vessel, where you've got gas coming in, gas going out, and they're driven by a common pressure controller, that's something you might also want to split out the controller, because it's an obvious common mode failure, and you want the team to really focus on that independently. Okay, so let's talk about consequences. Compressor goes into recycle. What does that mean? Again, I see that all the time when I pick up some work that's not necessarily the best quality. Something much better is to really say, well, what if it doesn't go into recycle? That's an action. That's an active event that may occur during your process upset. So you really find out that compressor going into recycle is usually not an ultimate consequence. The going into recycle is a safeguard, so you really need to not include safeguards with the consequence. So you want to drill down into how bad can it get, identifying the fact that maybe if something's occurred to cause it to go into recycle, maybe it's an overpressurization concern. Identifying the specific piece of equipment, tag numbers, P&ID references, also very helpful during the definition of the consequence, and taking it to its extreme. Now, you don't have to go beyond the realms of physics. If the laws of physics prevent you from achieving a consequence, usually you can take credit for those. It's the active safeguards that you don't want to take credit for when defining the ultimate consequence. So you want to take it all the way to its ultimate consequence, which it can include, in this little example, breach, release of gas, fire, and a personnel hazard. So you really want to drive it all the way to how bad can it get so you can do an effective risk ranking. And there's a lot of reasons to do that. We'll be talking a little bit more about how to make sure you're doing good SIL assignments for safety instrument and functions in a few minutes. So make sure that ultimate consequences are documented so you've got a clear definition of what those safeguards are, or those barriers between the causal event and the ultimate consequence listed out in your safeguards column, preferably as independent protection layers, so that you know exactly what needs to work to prevent that really bad situation. That's necessary because you want to be able to isolate that safeguard function later so you can put a reliability on it. More to come on that. You also want to, during the consequences, you want to illustrate event sequencing, and you also want to think about cascading consequences. While PSV might open up to protect a specific piece of equipment, that's great. In rare occasions, opening the PSV and having some sort of release can be have a higher severity than actually overpressurizing the piece of equipment that it was trying to protect. A good example might be a piece of equipment that's just overpressurized by a little bit, and the flanges might open, and you might get a small release of something bad. Well, if the PSV opens in that case, you need to think about, well, that could be a bigger hole that has a bigger release that has a lot of gas coming out. So these are the kind of things you want to think about when you're looking at the consequences, and also consider cascading effects. Again, it's all a matter of really thinking through the issues, being very specific with your documentation, so the team can understand during the session what is really going on, and they can really think about how bad can those consequences be. Let's talk about safeguards. Pressure control. That's not a really good way to document a safeguard. You want to go ahead and link it back to the controller or transmitter that's doing something and state specifically what it's doing. And in this little example, we're starting with PT or pressure controller. The XXX is obviously the control loop number here. When you do that, there's a number of software packages that allow have type ahead features. So when you're very disciplined about starting with a tag number, you could start with something like pressure control valve open, pressure control valve XXXX opens, and spell it all out. But that'll give you in the type ahead menu that comes up maybe a few dozen possibilities. If you start with the tag number, it'll pop right up with, if it's been used before, you can just grab it and make sure that if you're using a function that's a safeguard for multiple scenarios, that it's agglomerated properly and that you can appropriately understand the needed reliability. So that's very helpful if your software package does type ahead. Again, a patterning and discipline associated with this really helps save a lot of money and improves the quality of your overall HAZOP and LOPA. Also identifying, in this case, a control point. It makes the team think about the progression of the event, and the facilitator is responsible for reminding them, hey, is the safeguard effective? But if you spell it out, what the control point is, and you spell it out, what it's supposed to do, and you spell out that it's supposed to prevent overpressurization, in this case, of the condensate stabilizer column, they see it on the screen, and if that's not true, hopefully somebody on the team is going to say, wait a second, that's not an effective safeguard for this scenario. In the helpful example, they can do that. In the bad example that I presented here, they can't do that. So it's all a matter of effectively getting what you need from the team. Again, if you can't locate your safeguard in 20 seconds, it needs P&ID references. And yeah, I like to also make sure that the scenario progression and order of this is good. And also by identifying what it's supposed to do, what the effect of that safeguard is, it helps the team think about process safety time. We'll talk more about operator response, but even control features or pressure protection features in many cases need a certain time to react to actually mitigate the consequences. By controlling the documentation and adding this level of specificity, you can pull those things out of the team. Another example, a bad example, high pressure trip. A good way to do this is you put in a specific tag number for reasons I just described, referencing what ESD function, if it's an ESD function, and what it does. All those things are very helpful for making sure the team does a good job. I talked about the software type ahead features. Also by putting in specific control loops and making sure you tie it to the transmitter when appropriate or to the ESD function, you can help spot common mode failures. You can also, by being exacting with respect to partitioning the safeguards as independent protection layers, rather than reinventing the wheel if you have to do a layer of protection analysis, you've already defined your IPL and can go right into identifying the probabilities of failure and demand and the other things that you need to do during the LOPA. So having that segue to the LOPA is important, and also ordering the safeguards by event sequence, also really useful for understanding the scenario. And also, by making sure you put those tag numbers in there, there's so many times when the team hasn't really thought of how much time the operator's got to respond to alarms, what the progression of the events are. If a control valve opens up first, does it have enough time to prevent the high pressure trip by getting enough pressure out of there? So again, it's all a matter of getting what you need from the team to do a good quality job and have documentation that supports it. So let's talk about operator response. Again, identifying the specific alarms, identifying a specific set point, very critical. Identifying it may seem trivial, but saying, hey, this is going to trigger a control room alarm. I have had cases where I've had a team say, oh, this alarm, that alarm, and they were talking about some sort of local control panel. Well, if your local control panel isn't in a manned facility, it's not going to help you too much. So bringing these things out and being specific really helps make sure the team stays focused and is thinking about what's going on. And also, I invariably like to put providing the operator with sufficient time for diagnosis and corrective action. The operator has to be somewhere where they can hear the alarm. They need to understand the alarm. It needs to be clear. It needs to be a priority. They should be able to diagnose the problem from the alarm, or at least diagnose what to do about the problem. It should be clear. They may need permission for corrective action. They may need to initiate the corrective action, and then the corrective action needs to have its effect in terms of mitigating the ultimate consequence. So that's all part of getting the team to think about each time, is there enough time for diagnosis and corrective action? Getting it right in front of their faces and making sure they think about it. And of course, the facilitator reminding them is all about doing a good quality HAZOP study. You only want to include effective alarms. If he doesn't really tell the operator what to do or help with diagnosis, it's really not very effective. A lot of facilities during the design process are also not crediting alarms unless there's a clear priority associated with those, or it's categorized as a critical alarm. One of the dangers or pits that you can fall into here is if you identify a lot of safeguards that really aren't all that effective, all you've done is you've made a big long list of things that somebody thinks should be important. And if they think it should be important and you hand that over to your maintenance department, they're over there testing, calibrating, all sorts of instrumentation that may not be all that important. It's not only money down the drain, but they may be spending a lot of time on insignificant items instead of the important things too. Not spending time on important things in a large petrochemical facility can get people hurt. Also, the first item under considerations, grouping alarms as a single safeguard. If you think about it, there's one significant common mode item for all alarms, and that's the person responding. If the operator gets one alarm or 5 alarms, hopefully, as long as they're not confusing or contradictory, they can make a diagnosis, but they still have to diagnose the situation and take action. So I'll usually list them under, if somebody really wants to call these out, I'll usually list them under one safeguard, group them together so that it's clear that it's really one independent protection layer that you might want to pull out during your LOPA. Also, in terms of grouping things together, sometimes you got a compound safeguard. Usually, systems are designed so that relief valves are 100%. They can provide 100% capacity for relief. That's not always the case, and there may be sizing issues. There may be lots of other reasons why not to do that. If you need 2 valves to open up, as in this example, you want to make sure that they are listed as one independent protection layer or one safeguard, because the failure of either one in this case could result in not having overpressure protection. So you want to make sure that you combine them as appropriate to make sure that they're looked at as one independent protection layer. So let's talk about recommendations. Review I see this all the time. Review this, review that. Somebody can review it and say, oh, I read it last night while I was having a glass of wine, and I finished my action. Well, that wasn't the intent. The intent is usually to review it critically, identify if there's a problem, and do something about it. So it makes a lot more sense to avoid ambiguity, and in this particular case, identify what you're trying to do. You're trying to prevent overpressurization, identify equipment, and what you want somebody to do. Look into configuring a high discharge pressure trip is a specific action, and they have to respond to it specifically, not just say, yeah, I reviewed it over a glass of wine, I'm done. All right, so under considerations here, make sure the action's clear, minimizes the need for whoever gets it to have to find the HAZOP report, read it, and try to understand it. My experience is that rarely happens. If you're documenting your recommendations assuming that somebody's looking at the HAZOP study, that's a bad assumption in most cases. Briefly identifying the concern leads them to be thinking about, is the action adequate? And also including P&ID references and equipment tag numbers. Absolutely essential if you want somebody to do the right thing. So let's talk about a QA review. Yeah, if you do the HAZOP and LOPA study with the team, usually, and if it's going great, usually you've got some sort of checks and balances there. But realistically, once the report's done, it deserves a read-through, somebody critically looking at it. You don't want to redo the HAZOP and LOPA. In fact, that's how I think a lot of people fall down, is it's like such a big effort to really look through everything that a lot of times nothing gets done. So if you're trying to prioritize your QA review and really focus on things, do a completeness check. Look for anybody who's has experience doing HAZOP or LOPA knows what is likely to be some of the more significant failures in a process unit. Look to see if those are included, making sure that key causal events were documented. Ultimate consequences. You can spot check it. You can look at all of them. It's really easy to find those consequences where they said compressor goes into recycle, and it's a clear indicator that they haven't gone through and really thought about the ultimate consequences. Safeguards. Is there a correlation between the causal event and preventing the ultimate consequence? Have they been putting in some of the safeguards as independent protection layers? And if they started adding a lot of things like that are design characteristics or laws of physics, if your safeguard is that this temperature cannot be reached, well, that should have been you should squash the causal event and consequences without even getting to the safeguards. So there's a lot of things that you can see when you look at these if you're disciplined in the documentation approach. Scenarios have got to be understandable. Like I said, they should be showing you an image of a Hollywood movie as you're rating them. Risk ranking should be consistent. That's easy to pick up when you're doing a QA of a document. Actions, clear, complete, focused, with a focused basis, why they're doing it. You don't have to go ahead and repeat the scenario. You don't have to go through and write 3 pages on it. But some sort of trigger for why you're doing something can make sure that if there's a fundamental misunderstanding by the person who's implementing the action, they can ask a question. Recommendations or actions need to be self-standing, as I mentioned before. And if you've got a key thing that shows up a lot is when you've got, let's say you're in node 22, and you've got they're talking about high pressure. It's so tempting for a lot of teams to go back and identify, well, high pressure could have been caused by something else that occurred in another node, and to repeat the same thing. So when you've got the same causal events showing up over and over and over again, it's really inefficient. And it's wrong if the same causal event shows up over and over again with different answers. And I see that more often than just repeating it. I usually see repeating it, which is a real waste of time. And if it's got wrong answers, there's a problem because the thing hasn't been properly thought through. So a lot of potential for confusion. And also, if somebody's trying to use the HAZOP or LOPA later, and you've got the same cause, flow control valve 001 shows up in 3 different nodes, and it's not done properly in either any of the 3, and it's not synchronized, if somebody's trying to use the HAZOP or LOPA for MOC later, they can lead them to the wrong conclusion. They can make mistakes. You don't want to make mistakes, especially easily preventable ones like this, by just having discipline. You don't want to make mistakes in safety assessments. Just wanted to make a list of some of the things that we talked about in Module 10. If you want to go back to them, I'm not going to talk about damage mechanism hazard reviews today, safeguards effectiveness, action and completion status for validation, or ISD concepts. That's something that was discussed in the environment that existed a couple months ago in Module 10. It's going to get reviewed better on our upcoming webinar in January. And we'll be giving a complete regulatory update because this is a moving target. What's moving is some of these other elements. What's not moving are some of the fundamental HAZOP and LOPA quality issues, which is what we're discussing today. So, how do you control this? HAZOP and LOPA in general is chaos. And running a team, if any of you have ever done that, it can be quite chaotic. Now, in terms of doing a quality job, though, a programmatic and disciplined approach is really the way to go. Some tips: burying your head in the sand, as in the picture in the lower right, is not a tip. That's not what you want to do. If you're managing these programs, you want to show leadership. You want to make sure facilitation is synchronized. You want to provide patterned examples. You've all got copies of these handouts. You're welcome to use those. It's not proprietary. It's just best practice in terms of here's something that works, that's easy to do, relatively easy to do, takes a little bit more time, but you're going to save many more times that amount of effort later. Internally here, we keep a knowledge base on SharePoint of best practices, and also we work with a lot of different clients, so we also in our knowledge base have a list of what those individual clients like to say. See, everybody's got their own nuances. So there are ways to control the program, but like I said, burying your head in the sand is not one of them. So I mentioned before I was going to share with you some of the things that we've seen in terms of quality challenges. Causal event completeness. We talked about how important that was. It's very common when you don't have a well-prepared facilitator, when you don't have good PNIDs, and when they're not using a very disciplined approach to see gaps in terms of key events that they haven't done. These are challenges that people have. That's why you do a QA review. Ultimate consequences, again, it's very common to see where and it's so tempting. You know, your operator on the team, any of you who facilitated know this, the operator is always going to go like, oh, it's safe, it trips. Or, oh, we just go into recycle. Or the level control valve will control level. You know, it's so tempting because that's their world. They see these things working most of the time, which is what you want safety systems to do. And so they see them working and they say, well, gee, that can't happen. The facilitator, the HAZOP process, the LOPA needs to drive beyond that and really make people think outside the box, outside their normal realm of thinking in terms of what can go wrong. I'll just quote from a major oil company's guidelines. Underestimating can lead to insufficient layers of protection being applied and risk being insufficiently managed. So if you're not correctly identifying the ultimate consequence and listing the safeguard out, everybody, all practitioners realize that that is a potentially significant problem. The third bullet here, missing safeguards and overestimating SIL, that's another opposite end of the spectrum. If you're not clearly identifying your safeguards, when you turn that over to your instrumentation folks to identify a safety integrity level for a safety instrumented function, they're going to overestimate the needs, the reliability needs. So instead of a SIL 1 device, which is relatively easy to do, they may be designing it for SIL 2. SIL 2 is going to be more expensive, not only to buy, purchase, and install, but I guess that was redundant, purchase or install, but it's also a potential nightmare with respect to maintenance. You've got more equipment, more transmitters to calibrate, higher reliability targets to meet. All those things mean that overestimating SIL is not only expensive, but it can detract resources from more important safety issues. So not properly identifying basic process control system safeguards and identifying safeguards appropriately can have a more expensive facility with less safety. Again, another reason why you want to do a good job with the HAZOP and LOPA. Erroneous conclusions. I've seen so many cases where people use a safety feature as an initiating event. It really doesn't make sense. There are easy ways to handle that, but again, not doing a good job for the HAZOP and LOPA can have bad safety impacts. Not doing the LOPA properly, not identifying if you've got an unusual operating mode that you've got a lower initiating event frequency for control valve failure than if it's operating all the time. All these things are important to bring in there, doing a good job to the LOPA, making sure another common thing is if you've got an alarm and you've got a manned facility, typically the alarm condition is at the beginning of the upset. Operators will go out to the equipment to identify if it's a nuisance alarm or if it's actually a real event going on. If they're drawn to the problem and then for an overpressure event, pressure keeps rising, and then you have a breach or release, then instead of a vulnerability factor, assuming a random presence of operators around the facility, you've got one or more people right there on top of the problem. So again, these are common things that can come up during a LOPA that a lot of people don't think through properly. I talked before about certain software has type ahead. Using that feature can not only streamline your effort, but if you're doing that, I'll just mention one. PHA Pro has a feature such that you can list all your IPLs and all the scenarios that reference it, and it identifies the LOPA gap for each of those scenarios. That can help you agglomerate the challenges to the safety instrumented function to help you get a good safety integrity level. If you're randomly picking numbers, not picking numbers, if you don't use that cross-referencing technique, and then you hand it to your instrumentation designer, they're going to look through the list, find the first entry, and go like, okay, I only need a SIL 1 where maybe there are a lot more challenges to it. Okay, duplicating scenarios. Again, very time consuming. If you keep analyzing the same thing over and over again, you're probably not going to have any new conclusions. All you're going to have is a big mess in your HAZOP where you've got multiple scenarios with different answers. And then later on, you're going to be trying to figure out what's the correct answer. Evaluation of vendor packages as separate processes. This is a big time waster that really degrades the quality of the HAZOP study. A lot of times vendor package details aren't available till later in the design process. So the team is tempted to just forget about it during the initial HAZOP, look at the process stream, and talk about loss of flow. Let's talk about a compressor package. Loss of flow to the compressor. And then they'll look at the other side of the blank box early in the design, and they'll look at loss of flow from the compressor. Fine, that's great. But then, months later, years later sometimes, when they get the vendor data, you got a different team, and the different team has to look at loss of flow to the compressor and loss of flow from the compressor. You're duplicating your effort, you're leaving yourself open to having a lot of inconsistencies, and like I said before, the same safeguards may be in so many different places in that cross-link that you may not be putting the appropriate reliability on them. Equipment tag numbers and P&ID references, this is probably about the half dozen mark here, super important for saving time later and also improving quality. The team is super important to maintain consistency. If you can get your job done with a small dedicated team during a large design process, you will reap the rewards later from a consistency perspective and also doing a good quality job. For multi-team projects where you've got several different teams working on a HAZOP LOPA during the design, making sure that you've got a lead facilitator who's responsible for setting the pace, setting the examples, and maintaining a consistency and quality, super important. If you don't assign a lead facilitator, everybody's going to go into a lot of different directions, and you're not going to have the results that you want. That lead may also provide synchronization training. We're not talking about a 3-week course here, but to get together for a couple hours and just make sure that they're all synchronized with respect to best practices and what to do there. Focusing on long-term objectives. I've mentioned about saving time and using the product later. Invariably, when you're only focusing on the issue of the day and you're not thinking about how your HAZOP or LOPA product can be used years down the road, you're not really going to be setting it up so it makes it easy for people to use, update, and save time later. So again, think outside the box a little bit. Think of how it's going to be used for MOC, SIL assignments, future revalidations, and you'll have a much, much better product. Also, if you're doing a large design project with multiple facilitators, multiple teams, wait until the very end of the project. After everybody's disbanded, everybody's gone home, the design is frozen, to start doing your quality assurance review of your HAZOP or LOPA. Well, if you do that, you'll know why it's not a great idea and why you'll reap the benefits if you start synchronizing and doing QA reviews earlier. So these are the key challenges that we see both on a specific documentation level and a structured environment for running large HAZOP LOPA projects for large designs. I hope you'll look at this and realize these are common things that people do and find ways to avoid them. The whole thing revolves around using resources, sessions, and documentation to try to maximize the usefulness of the PHA, how you're going to use it later. We talked about documentation traceability, approach standardization, using risk ranking properly, grouping of scenarios. I like to use a very patterned approach for the deviations. Go methodically from the start of the process to the end of the process for each node to make sure scenarios are grouped so I can find things easier later. I love updating my own stuff. It's like I can go in there and it's all the details are there, the pattern's there, it's grouped properly, and I can just jump in and make updates or whatever. If you do this properly, you'll really reap the benefits. We talked about qualifications and experience. Large noting can also be helpful. And here we go again. Equipment tag numbers, P&ID references, and cross-referencing. You will save time. You will reap the benefits. It may seem like a pain in the neck as you're doing it, but in the long run, you're going to make your products more useful, and you're going to be saving a lot of money in the process. Evergreen, thinking ahead, think about the long-term use of the PHA, and again, make sure any software you're using is going to be usable in the future too. Whatever you do a lot of these things need to get updated every 5 years. So what you do in 2014 is going to have ramifications for you or someone else in 2019, 2024, etc. All right, I'm going to sip a coffee because I've been talking a lot. So this is, as I mentioned before, Risk Management Professionals has a pretty entrenched outreach program. We also make sure that we rotate the presenters, so it's not just me, and we provide equal abuse to all the folks in the office. And but I will be involved in the next one. Myself and Jordan Schultz on January 14th. We'll have a webinar that looks at the new regulatory framework for PSM and RMP. California is kind of a hotspot for the regulatory evolution. The CSB has had a lot of recommendations on that. We're going to pull all that together in hopefully a fairly sensible manner about California and what's going on nationally in our January 14th webinar, and we'll probably be revisiting or at least tuning up a little bit the PHA methods and quality issues that we just discussed. So this allows us to open it up to questions. And I also wanted to talk about our future webinar to give you time to think about questions. I'm happy to take any comments, questions, or abuse that you want to throw at me. You can do that via the chat window with Tim Lee, and he'll reiterate the question. He'll restate it on his mic, and then I'll attempt to answer it. And I'll be happy to address anything you guys want to address. I want to thank you for stressing tag numbers. Your mic's on, right?
So we had a comment, and the comment was that the person wanted to thank us for stressing tag numbers and specific information to be identified in the scenarios and recommendations. As an auditor, it is very time-consuming to evaluate the effectiveness of the PHA when the typical bad scenarios are used. It really is a trigger for a compliance officer to spend more time looking at the PHA and asking a bunch of questions. A first impression on the PHA goes a long way with regulators. Thanks.
Good comment. Thank you.
We have a question also. Do you recommend always doing a LOPA in conjunction with the HAZOP? There seems to be two distinct opinions about this. Some say no, a HAZOP is sufficient, and a LOPA can make a HAZOP so large it becomes ineffective. And others believe that a LOPA is beneficial, especially when added to definite aspects of a HAZOP. Your opinion?
Okay, that's a great question. In the LOPA kind of came into the fray in the early 2000s when people started applying it commonly. At that time, most people did consider it a separate animal. So when it first started getting used, it was done by a separate team. The leap from a semi-quantitative risk ranking in a HAZOP to a little bit more definition of reliability items in a LOPA was considered different, and it was considered that different skills were necessary. As time moved on, a lot of people, my early career was in quantitative risk assessment. So there was a lot of, for me it was just one large spectrum of different types of tools, but people had considered it separate when LOPA first came out. However, how that's evolved is it's more common right now to infuse the LOPA right into the HAZOP study. For example, as you're looking at one specific scenario, and the team's warmed up, they understand the process, they've thought through the process dynamics,
and then to go through and use that understanding and clear definition of safeguards as IPLs and clear definition of consequences as ultimate consequences. If you're careful with structuring the HAZOP, which you should be anyhow, segueing that or transitioning that to LOPA is very straightforward. And if you do that during session, our experience is it may add an extra 10 or 15% to the overall time of the study, but it also gives the team, especially for the high-risk scenarios or high-consequence scenarios, which are the ones you want to do LOPA for, it gives the team a little bit more time to think. Doing the LOPA gives a little different perspective, a little bit more insight, and those are very valuable. And a lot of times, maybe 10% of the scenarios that we actually apply a LOPA, there's some new insight or some new information or some new conclusion that can be drawn that's very valuable. So I would say that it is a little bit extra effort. It's less effort if you do it with the team, as long as you got the right team and the right facilitator who can do this properly. It's most efficient, and the amount of extra insight that you get exceeds the amount of time that you put in. So I would call it very cost-effective to do it like that. Now, all that said is there are still people who do it separately. My observation, it's a lot of extra work to do it separately.
Next question. Any recommendations on use of screens in the room, clearly communicating the nodes to the HAZOP team?
Clear communication of nodes is important. Good question. I found a lot of the old school approach to HAZOP is for the facilitator to show up with a blank sheet of paper and not having reviewed anything. That's not something we endorse. We talked about why that's a bad idea in the first place. What the facilitator should show up with is having reviewed the drawings, defined the nodes up front, and highlighted the nodes. There's ways to do it electronically. You can just use an old-fashioned highlighter and make photocopies, and then that's presented to the team to provide that initial structure. So, rather than have the team argue the node structure, the facilitator should come in based on the facilitator's experience, understanding the process, come in with a node structure that makes a lot of sense and will really focus the energies of the team.
Do you recommend using risk ranking before safeguards to drive selection of scenarios for LOPA?
Okay, very good. By risk ranking before safeguards, we'd usually risk rank the consequence severities. That's usually very helpful to avoid pollution of the team members' minds in terms of thinking ahead for the safeguards, so that you've got it on the screen and you get a specific severity ranking. Then when you put the safeguards on the screen, then you can talk about what's the likelihood of getting to that ultimate consequence so they can clearly risk rank. That's the preferred way to apply a HAZOP risk ranking. It also makes sure that the severity ranking for the consequence can be easily translated to the LOPA. And again, you haven't polluted your discussions on this. There have been cases where, in fact, one of the major oil companies' key methodology is also to provide a ranking of the initiating event frequency and that ultimate severity, and then a separate likelihood ranking of getting to the ultimate consequence. It's sometimes useful, but it's not necessary. And sometimes it can add to some confusion too. So I think our recommended approach typically is going to be clearly identify the ultimate consequence, lock in the severity ranking, which also feeds to LOPA, then list your safeguards, and then finish your likelihood ranking.
There's an inconsistency in the industry around taking how many credits for BPS. We limit only 1 credit for BPS. What is your take?
Okay. If you take more than 1 credit, you should be very, very careful. The key issue is common mode failures. BPCS type equipment can include common logic solvers. There may be other elements in common that aren't apparent from the P&IDs. So typically, you'll want to make sure that you've got your instrumentation on the team is on board. And if you're taking a BPCS safeguard credit when you've got a BPCS failure that's your initiating event, you have to be careful. If you're taking more than 1 BPCS credit in your safeguards as independent protection layers, you want to make sure they're truly independent. and your instrumentation person can identify that. So unless you really know that it's independent, it's usually recommended practice to start with no BPCS if you get a BPCS failure in your initiating event, and if you've only got one BPCS failure, and only have one BPCS safeguard for your initial credit if you don't have anything in your initiating event frequency. Take a look at that, see if it's driving you towards very high SIL values for your safety instrumented function, and then step back and get more information and more details if you need to. That is one of the advantages to also, back to the previous question, to applying LOPA early on in the process, because you can identify if you're really challenging the SIL levels that you want for your safety instrumented functions, and if you are, get the team to rethink, are we missing something with respect to vulnerability factors, the progression of the event, that is really driving us towards SIL rankings that are very difficult to do. And actually, I'm going to ask, did you have some other comments to make? Actually, we're going to pass the microphone to Mr. Colin Schultz. He's going to provide some additional clarification, and I was looking forward to that anyhow.
Yeah, I just wanted to make a comment that in the documentation for safeguards, sometimes it helps whenever accrediting interlocks or process control systems to put in parentheses what control system that safeguard relies in. So, for example, a burner management system or a compressor PLC or the plant DCS. And that helps illustrate it for the team to figure out how many logic solver systems that they have and are crediting.
Exactly. Very good. Thank you for the clarification, Colin. Next question.
Which of the common quality challenges that you mentioned are most likely to lead to added costs for HAZOP/LOPA?
I'm sorry, can you repeat that?
Which of the common quality challenges that you mentioned are most likely to lead to added costs for HAZOP/LOPA?
Okay. Let's go back to those. Are you able to get to this screen, Tim? Okay, great. This is one of the previous slides that we looked at. One of the key, in terms of quality challenges and cost associated with that, not using the software features that are in the software packages that can help drive consistency, make it easy to assign SIL values, and really simplify the documentation of the HAZOP and LOPA. That's a key one. Duplicating scenarios has got to be the biggest one. It's really tempting for some old school facilitators or some teams to, when you're talking about consequences in one area, to start identifying causal events in another area. Having a disciplined approach so you're only identifying causal events in the node that you're looking at and really carrying it through to all the different types of consequences, making sure the scenario development is complete. Do it once, do it right the first time. You're going to save yourself a lot of money later. I don't know how many times I've picked up large efforts and see the same scenario 3 and 4 times, and in none of the 3 or 4 locations it's done properly, and it's just a lot of wasted work. The vendor packages as separate processes, again, evaluating the same scenario over and over again. If you're looking at the main part of the process and a loss of flow, and then you look at the vendor package months later and look at a loss of flow going into the vendor package, it's the same thing, same effect. Why repeat this? Why redo the analysis? Do it right the first time and do it once. And as we mentioned before, the equipment tag numbers and PNID references may seem like a pain in the neck. You will save lots of time if you look at the amount of time to use the product later. So I think those are some of the big ones that can impact quality and also take a lot of to really increase the cost of your HAZOP and LOPA.
What is the minimum experience level that we should be looking for in a facilitator to ensure quality HAZOP/LOPA is done?
A lot of companies go with 10 years, 20 years, whatever years of experience when they're trying to formulate their programs and get facilitators on board. There's good and bad to that. Experience is good if it's the right kind of experience and if the person that you're having facilitate has what it takes, has the right qualities, and can really drive the team. But the facilitator also needs to be tuned into contemporary requirements, how the software works, contemporary design techniques, and safety instrument functions, and a lot of instrumentation issues is what makes a really good facilitator. So I would have to say, kind of beware for, well, I guess I shouldn't talk, but beware of folks with gray hair. The reality is that a lot of folks are still doing things that are the way they did it back in the 90s, and that just doesn't mesh with contemporary requirements and what regulators are looking for. So realistically, rather than age or years of experience, look for qualifications. Look for folks who are real sharp, can think on their feet, can do a really good job, and really drive that HAZOP team to really finding potential gaps or weaknesses in the design or operations that can be addressed as part of your safety program. Tim?
If you have the luxury of having low turnover of staff, do you recommend having different PHA team members participating in a PHA or staying consistent on the members over the years?
That's a great question, and the only answer I can give is it depends. It really depends on the team members. If the facilitator really drives the team members to do a good job, and the team members have the right qualifications and are really good at thinking outside the box, yeah, keep the same team. They already know what was discussed, they know the issues, and they can not have to reinvent the wheel or rediscuss the issues, and then they can focus on the important things that have come up, use their experience and insights to really look at the new or the more important issues. I have had people on my teams before that I've asked to not come back again. The reality is not everybody, and you'd like to think that everybody can do this stuff, or HAZOP, LOPA, it's so easy, any fool can do it. But the reality is a lot of people are better tuned, they're better equipped at thinking how to make things work, how to make it run smoothly, and they're not as critical when it comes to what if something goes wrong. What happens if the thing is outside the framework of what I designed it for? And if you've got folks on your team like that, they're not going to be very helpful in really finding any gaps or deficiencies in the HAZOP or LOPA, and you really need folks on your team who are going to be looking for that stuff. So that's why it depends. It really depends on the team, and a good facilitator can also flesh that out. A good facilitator will know literally within minutes, if not a couple of tens of minutes, if somebody's really not going to be able to be a contributor.
Is complete documentation a time-consuming process?
Good question. We've talked about a number of ways to make your documentation usable, provide specificity, and provide detail in it. It doesn't have to be ominous. You can do little things that don't take a lot of time to really improve things. And I think, as I mentioned before, the scribe is there to, if you give them clear direction on what you want, most of the specificity can be brought into play during the actual sessions, during those few moments of dead time between arguments, between discussions of the team. And for those few minutes of dead time, the scribe can go and put in some of that more robust information to really save time later.
Does the level of documentation required for a quality HAZOP LOPA need to be the same for all systems in all industries?
Great question. A lot of the really complex processes, you really want to be careful about PID references, tag numbers. You can take some liberty with that if you're dealing with a simpler system. If the whole thing fits on one PID, and if it's a fairly simple chemical distribution process, you can take some liberty with respect to documentation shortcuts. The key thing is usability. Is somebody going to be able to pick it up and use it later on? That's where the rubber meets the road. Tim?
And the same person who asked you regarding the PHA team members participating in a PHA, staying consistent over the years, commented saying, I find that a team often forgets to evaluate the near misses or incidents that have happened in the last 5 years since the last PHA, and a team does not evaluate the consequences and root causes of the failures in the PHA.
All right, fair comment. You really do need to make sure that the team is thinking and looking at the key issues later on. One of the things I do with revalidations too is I make sure that a lot of the high-risk ranked or high consequence ranking, or both, actually, scenarios get a complete review. So, it's okay if you want to take, during revalidation, to go ahead and give a quick review of some of the less important items. But for high consequence or high risk rank scenarios, you really want to spend more time with it. And I didn't quite understand the first part of the comment on the near misses. It is a requirement when you're looking at updating a HAZOP study to specifically bring into play incidents that have occurred, and your incident reporting system should be picking up near misses. Now, the reality is there's a lot of challenges in doing that. There's more judgment in terms of the importance of documentation and tracking of near misses when it comes to incident investigation and incident reporting. But realistically, any near miss that has the potential to cause a significant process safety event should be in your system and tracked, and that tracking should be used during the team discussions for PHA updates. Colin, did you want to add to that? Okay. Tim?
Why is overestimation of the SIL value a problem?
Okay, really good question. If you're leaving out key safeguards and you hinge all your protection for a large, high-severity ultimate consequence on a single protection feature, if you're not considering all those other things that can come into play, then you're going to be putting a very high SIL value on something that really may not be that important. So what does it mean? It means money, extra cost, capital cost, and also maintenance. And also means that you're focusing on a safety device that may not be that important. Maybe something else deserves more attention. The whole thing about HAZOP and LOPA is about providing balance. You're trying to do the HAZOP and LOPA to find vulnerabilities, deficiencies in the design or operations, and you're trying to take your resources at a facility and really focus it on the areas of the most importance. That's a key part of what you're trying to do for HAZOP LOPA. Everything we've discussed with respect to session organization, quality documents coming into the session, and also quality documentation of the HAZOP, it's all about that. And making sure that when you're all done, you're applying your resources in a way that focuses on life, the environment, and property. Tim?
Sounds like that's it for questions and comments.
All right, very good. All right, well, let me thank everybody for their participation and attending today. A lot of good comments. Really appreciate the good questions, too. If you have anything else, just give us a call and stay tuned in for more of our outreach program. Thank you very much.